So let's just look at this is a little simulation of how energy system works generally. So I'd like us to pay close attention to this. Now, in every energy system, um, there is energy conversion from one form to another form according to the law of energy balance, that energy can neither be created nor destroyed but can be transferred from one form to the other. So I just want us to look at this diagram. Now this guy is cycling, and as a result of that, he's powering this generator. That this generator transfers that energy to this light bulb. So this guy keeps cycling, and the more I move, I can increase the speed by just moving this. But a time will come when this guy gets tired, complains, and I gave him something to eat, continue cycling, and continue cycling. And the more he cycles, the faster he cycles, the more the energy generated. Now, but the question is, how long can he do this? So he cannot be doing this all the time. So in the industry, there are different ways we can make this work. I can replace him by just using, let's say, this pump, for instance. So as long as the pressure, is high, and this fluid or this liquid is running from this tap, it can power this generator. It can cause that generator to rotate for some time, but something needs to be pushing this. Something needs to be doing this to power this generator to generate the light bulb. Okay, now, but we are in a system, we are in the time where there is so much emphasis on renewables. So it's also very good for us to know how renewable energy work. I need to explain this before I explain the hydrogen system, because everything is connected, the same principle. Now, for the renewable, this generator will be replaced by, let's say, a solar panel, for instance, and this liquid, of course, will be replaced by the sun. Let's say we are trying to build a solar system, and you can see clearly that as long as the sun shines onto the panel, it generates electricity. But let's say I created some clouds around the sun. You can see the more clouds we have, the lesser the amount of electricity generated. So this is just a picture of how energy system works. Now I'm going to explain how the hydrogen system works, because when we get our understanding, we begin to see the jobs, we begin to see the career opportunities in the hydrogen system. Now this is the hydrogen system. We have the various sources of clean energy. We have the sun, the wind, water. These are sources of clean energy. Going through what is called an electrolyzer. An electrolyzer will convert the electricity from this source or the energy from this source into hydrogen. And this hydrogen can be stored or be used to generate electricity. To use this hydrogen to generate electricity, it has to be passed through the fuel cells. And a fuel cell can convert this hydrogen to electricity or to heating that can heat up our homes and anything. So as you think about these two systems, the question that will come to your mind is, what are the career opportunities that can arise from this hydrogen energy system? So that takes me to the first question I want to ask today, that how many jobs can you see within the hydrogen economy? So we are talking about the hydrogen economy, the value chain in the hydrogen economy. So currently in the UK, there are up about 75 jobs that can come from the full realization of the hydrogen economy. 75,000 jobs, that these are potential jobs. And this was carried out based on a study conducted by a group called the Hydrogen UK, and the Hydrogen UK's own perspective analyzes the the they own an analysis that provided insight to the amount of jobs that can be created. So, as of 2020, the economic impact assessment shows that investment in hydrogen could unlock up to 18 billion pounds in that's in gross value, the gross value added that can come from that, and about 75 jobs in the UK by 2035. So this shows that there are a lot of potential if the hydrogen economy is operating at a full scale. So as we begin to think about this hydrogen economy, the next question that will come to your mind is, which sector will benefit more from this hydrogen economy? So when I mean by sector, I'm talking about in terms of what we can use hydrogen for. So for instance, in heating our homes, um, in um, in driving our cars, in the industry, in mobility, yeah, it's just like transport, for instance. These are some areas where we can apply hydrogen. So you begin to ask yourself, what are these sectors that hydrogen can be applied? As you begin to ask yourself those questions, you begin to see the potential uses of hydrogen and also the potential jobs that can come as a result of hydrogen being utilized in those sectors. So this takes me to another question. How many hydrogen vehicles do you think are on the UK road as of today or as at January 2023? So it would have been very good to hear your perspective, but just to save time, we have 300 hydrogen vehicles as at January 2023. And in Aberdeen, where I stay currently, there are almost all the first bus, the transport bus here is the first bus, have converted to hydrogen. So most of them, I'll say about 70 to 80% of the first bus runs on hydrogen at as of this moment, as I speak to you. And there are some other vehicles, even in Glasgow and some other towns in Scotland that also runs completely on hydrogen. So the number as of today, this number of 300 is at as at January 2023, but as of today, this number would have significantly increased. So let's talk about the hydrogen value chain. And if you want to read or know more about the hydrogen value chain or the hydrogen system in the UK, I would strongly recommend you read a document on the UK hydrogen strategy. You can easily Google that and get that online. First of all, let's talk about the different types of hydrogen. So we have what is called the gray hydrogen. The gray hydrogen describes hydrogen produced from hydrocarbon, typically through steam reforming. Um, so steam reforming is a process of just like the name, reforming methane into valuable products. So this type of hydrogen is produced from steam reforming process. But the problem with the steam reforming process is that it produces carbon dioxide. So carbon dioxide is a byproduct, and a lot of energy it's required for this steam reforming process. So there is another way of producing. There are other ways of producing hydrogen. The other one is the blue hydrogen. So this refers to the gray hydrogen that is produced in combination with carbon capture and storage. So these try to mitigate the negative effects of the gray hydrogen, which produces carbon dioxide, by incorporating carbon capture and storage. But the one that is um very attractive is or very clean, or has the potential to be very clean, is the green hydrogen. And the green hydrogen is produced by water electrolysis. that is supplied by renewable generated power such as wind, solar, and tidal power. So this is one of the most promising way of developing hydrogen that will be very clean for the environment. So let's see the stages in the hydrogen economy. And there are various stages from the production of hydrogen to the storage, transportation, and utilization. These are the four key stages. And each of the stages has their own challenges because hydrogen it's kind of a unique kind of gas. It's not very, for instance, it's not very easy to store because of its chemical properties and its physical properties as well. Hydrogen is not very easy to transport because it loses a lot of efficiency as a result of being transported, and it's not easily currently it has not been effectively utilized to other means of producing electricity, for instance. It has not been maximized at a very huge commercial scale. So it's a process that is still, going undergoing design and research, and you know a lot of work is being put into the process of developing hydrogen at the moment. But let me just take us through the various stages and just highlight some of the jobs in the hydrogen value chain. Now, when you think about the hydrogen value chain, there are three streams you can think about: the downstream, the upstream, and the midstream. Now, the upstream is close to the source. It's always think about the upstream as going close to the source. For instance, in crude oil exploration, the upstream would be going to the sea. For instance, the North Sea here in Aberdeen to explore the crude oil. That's upstream when you try to go close to the source. The midstream is when you have explored the crude oil and is being maybe transported or being used or being produced just close to the source, a bit close to the source. But the downstream is where you are taking this product, the refined product, where you are refining the product to be used in the homes, in the vehicles, and all that. So hydrogen also has those key sectors: the upstream sectors, the midstream sectors, and the downstream sector. Now, for the upstream sector, Jera, potentially we have up to about 28,578 jobs. For the midstream sector, about 15,437 jobs within the UK by 2035, as predicted by the Hydrogen UK publication. And in the downstream sector, we even have more jobs in the downstream sector, about up to 30,631 jobs in the downstream sector. So this is the total um, potential jobs in the UK for hydrogen. So this is where we can use hydrogen in the downstream sector, for instance. In the downstream sector, we can use hydrogen for transportation. So that will give us about 8,493 jobs. In the industry, hydrogen can be used. And in our buildings, we can use hydrogen to heat our homes. So we have hydrogen boilers currently in use in some homes, and that potentially can create up to 9,591 jobs. And in power generation as well, hydrogen can be used to generate power. In the midstream, you can think about transmission of power distribution and energy storage. Energy storage is one aspect of energy that is gaining more attraction, in the industry these days. So much investment are going towards energy storage. Now, for instance, this chart just shows how hydrogen has been utilized so far in Scotland, the number of companies in the hydrogen value chain. So you can clearly see that there are 48 companies as of this year that are currently involved in building hydrogen infrastructure. So in those companies, they are responsible for installing and commissioning hydrogen infrastructure, and also in the operation and maintenance of hydrogen infrastructure. In terms of hydrogen production, there are currently about 11 companies, mostly involved in the material and the components, creating, designing those materials and components, the hydrogen manufacturing, and the equipment manufacturing for hydrogen production. Then we have the hydrogen transportation, distribution, and storage, about 21 companies. And in terms of monitoring and controlling hydrogen, about 7 companies. For support functions, such as professional service, research and development, we have up to 44 companies, mostly academic universities who are researching on hydrogen. And for hydrogen carriers and transport, about 8 companies in the UK. So this is just the map of different companies in Scotland at the moment. This in the whole of England, or in the whole of UK or England, this will be significantly higher, because Scotland is much smaller than England. And so when we think about the hydrogen value chain, there are some jobs that comes to mind, and this is what I really want to show us today. For instance, the hydrogen production technician, the hydrogen plant engineer, the hydrogen storage specialist, hydrogen transport managers, the fuel cells engineers, and the environmental scientists. So these are some of the jobs that comes to mind as you think about this hydrogen value chain. But there are other jobs, of course, such as project management, business management. All these other jobs will be connected, but these are just people, the key people involved in building the hydrogen system, and making sure that the plant is running, the hydrogen plant works. These are people involved in the day-to-day running and operations of the hydrogen system. So here are some list of companies who are involved at the various stages of the hydrogen value chain. For instance, in production, you can think about the Air Liquide, the Linde is also a very well-known company. Siemens Energy, they are also doing very well. In terms of storage, you can think about the ITM Power, the Mach5, and the Cummins. So these are some of the companies doing well in hydrogen storage. In terms of transportation of hydrogen, Air Products is very good. Nikola, Plug. So these are some of the companies there. In terms of utilization, Ballard, Fuel Cell Energy, and Toyota, of course, which they have their hydrogen cars. Now, what are the skills needed in the hydrogen value chain? So these are another very important aspect of today's conversation. So you need to be thinking about these skills. If you're interested in hydrogen carrier or building a hydrogen carrier, these are some of the things you should be looking out for. Again, if you look at this chart, this table here, you can see that some of the skills are very strong currently in the industry. For instance, the process industry. Within the process industry sectors, we have the monitoring and control, and the compressors, and the liquefiers. These are well-known technologies currently used. But in terms of gas transmission, small scale chemical sectors, in terms of pipeline transport, bulk storage, hydrogen carriers, fueling facilities. These are areas with just moderate skills at the moment. Things like development of hydrogen infrastructures, installation and commissioning of hydrogen infrastructures, operation and maintenance of hydrogen infrastructures. Currently, we just have moderate skills in those areas. And areas where the skills are really weak are areas such as the green hydrogen production and the CO2 capture from hydrogen production. These are areas where much work are still required to be done. So as you think about your own skills or your own interests, try to align yourself to one of these areas, and that's how you will eventually build a well-made, meaningful career in the hydrogen sector. But before we come to an end to this presentation, I'll just run us down through um, some of the roles in you will find in this hydrogen economy. So you have roles such as developers, installation and commissioning, operation and maintenance. So people who do these jobs are mostly working in engineering consultancies, in oil and gas companies and process plants. So these are some of the things you find in terms of hydrogen infrastructure. In terms of hydrogen production, the people who work in this area, they are more concerned about the materials and the component development, hydrogen um, manufacture, hydrogen manufacturing equipment as well. So these people are mostly skilled in water electrolysis, and also they have knowledge of existing plants, trying to transfer the knowledge of existing plant in developing the hydrogen plant. Another thing we see in the hydrogen value chain is the hydrogen transport and distribution and storage. Here we have mostly people who are involved in gas transmission and gas storage. And in terms of monitoring and control, this is mostly done by the process industry sector because it's a well-developed industry. And these people with this experience of monitoring and controlling gases can also use that skill in the hydrogen economy. So in terms of the support functions, we have professional services, R&D, education, um, ancillary services, and mostly researchers from the universities. So if you want to be a hydrogen production technician, these are just some of the skills you need. You need to have some technical skills, pay attention to details, and have the problem solving skills because your responsibility mostly will be to operate the hydrogen production equipment, ensuring safety protocols, monitoring hydrogen processes. If you want to be a hydrogen transport manager, you'll be responsible for planning hydrogen transportation, ensuring timely delivery, and managing hydrogen logistics. You will need to have very good organizational skills, communication skills, and problem solving skills. If you want to be a fuel cell engineer, you'll be responsible for designing and developing fuel cells, testing and improving efficiency. The skills needed are engineering skills, creativity, and analytical thinking. If you want to be an environmental scientist within the hydrogen economy, you'll be responsible for studying the environmental impact of hydrogen use, suggesting sustainable practices. The skills needed are research skills, environmental awareness skills, and data analysis. If you want to be a hydrogen safety consultant within the hydrogen economy, you'll be responsible for studying and designing out the risks associated with the use of hydrogen and suggesting best safe practices. You'll be required to know skills such as risk assessment, hazard identification, environmental awareness, and data analysis. And once again, these are the companies um, that are currently involved in the hydrogen economy value chain. If you have any interest in the hydrogen economy value chain, I would strongly recommend you begin by looking at the website of these companies, identifying the skills you need, and try to build your career along those lines. As I bring this to close, I want to ask this question. If you are a student interested in a career in hydrogen industry, what step would you take to prepare for such career? And this question is very important because it makes you think about what you just heard and how to position yourself to be relevant in the hydrogen economy. Another question I would like you to think about as we come to the end of this presentation is, what question do you have about career in the hydrogen industry? And I'll be very happy to take your question before um, we come to the end of this presentation. But I just hope and I just hope you've been able to learn one or two things about the carriers in the hydrogen economy from this presentation. So if you have any question, you can ask me before we go today. All right, so I want to assume there's no question. Okay. That will be the end of the presentation today. Once again, thank you for inviting me to speak on this. I just hope you've been able to pick one or two things, and I'm happy to deliver this